Okay, hi everybody. In this video, we're going to start with an introduction to the material in Chapter 6, which deals with estimations. We're going to talk about a couple of methods that we can use to estimate parameters in a statistical model. Okay, so for example, let's say a biologist is studying black bears and they want to come up with a model for the distribution for the weights of newborn black bear cubs. How much does a newborn black bear weigh? So they take a random sample of 10 cubs and they record the weights in ounces of each of those 10 cubs, and that's what's shown over here. And looking at this data, how can we come up with a model for the distribution of the weights of all newborn black bears? And so the first part of this process would be to come up with what's a model that we could use to describe the data that we've observed here. And so if we look at this data, we've seen some distributions already that, most of the weights are kind of clustered in the middle, a little bit less than 10 ounces. And then as we move away, either greater than that or less than that, we can see that the values get more sparse as we move away. So the further we are from the center, the less and less likely we are to observe observations. And we also see that the data looks somewhat symmetric. So for all of these observations, we might first just look at the data and say, well, what model would make sense to fit that data? In this case, I think we would have a pretty strong argument to say, well, we should use a normal distribution to model this data. Okay, here's a bunch of normal distributions that we can overlay on top of our data. And so once we pick a model based on, say, like the shape of the data, the next thing we would need to do is there are all kinds of different normal distributions. So which normal distribution fits that data best? So you can think about this in some sense as like a curve fitting sort of problem. We have all of these different curves in red, blue, yellow, and green, and which of them seems to model the data that we have over here the best? Well, as far as normal distributions go, there's only two parameters that determine the shape of a normal distribution. So we have parameter mu, which is going to tell us where's the center of the normal distribution. So for example, it seems like the one in red and blue and in yellow, they all have the same center. The graph in green has a center which is like about 8. So we could probably rule out the green graph. And now we've got these three graphs to work with. But of course, we need more than one parameter to describe a normal distribution. We also need to consider how spread out those values are. And so these three normal distributions in red and yellow and blue, they all have different spreads. And so looking at these, then we could probably start to think about which of these three distributions has a standard deviation which seems to match our data. And another way to state this is given that we've recorded these 10 values, which of the parameters mu and sigma are most likely? So which of these curves is most likely to fit the observed data? And so this is the process of what's called a maximum likelihood estimation. And so this is the topic in the first section in chapter 6. So the process is going to be we collect a sample of data. How can we first come up with a guess for what model describes our data, and then how can we find the parameters in that model that would be most likely to occur given our observed data? So let's just take a look at one more example informally to make sure we understand where we're heading with this.